So the next place I wanted to go was taking a look at this thing that I mentioned at the beginning of the stream, which is, um, there's different there's different types of programming you want to use based on what you're doing, what kind of products you're working on. And one thing that I've always been really interested in is game programming and game development. And there's a couple of reasons for it. One is that I've always just been really into games. You probably can't see it with the way the video is cropped here, but I've been really into games since I was a little kid, starting as far back as like the Atari 2600. But was got really into the Nintendo and the Super Nintendo, and then have just kind of stuck with gaming throughout my life, and still play games occasionally. I just streamed some Celeste last night. So yeah, it's kind of been a hobby of mine for my whole life. But another thing that I find really interesting is it's such a different mindset that you have to get into when you're programming for games, because you really want to get the most performance you can out of your machine, especially if you're going to be doing like 3D games, anything that's I would say AAA games, but really, if you're doing any kind of game, you just kind of want to get the most performance out, because the more efficient you can be, the more things you can throw into the game. Like if you want to have more animation going on, or if you want to have, especially in 3D games, like if you want to have more detail, or like a further distance out that you can see where things are a high level of detail. Or if you want to add things like lighting or volumetric lighting, or particle effects, or there's just kind of like, you're always resource constrained in video games, unless you're making like a pixel art style game. There's cases where you're less restrained, but you still do kind of want to get the most out of the hardware that you can. And it leads to a few different things happening. And the reason I have this talk up here is this. There's a couple of people who I've been following recently who are really good video game programmers who have been putting out more and more videos. So if you're familiar with Braid or The Witness, that was created by Jonathan Blow. That's not this guy. This guy is Casey Muratori, and but they work together. And I think they've both been in the games industry for 30 years. 25, 30 years, something like that. But he does a lot of he has a lot of very good videos for people I'll say, like, for me personally, just caring mostly about, writing Ruby and JavaScript in these higher level, generally like interpreted languages. He has a lot of really interesting talks about doing things at a lower level, doing things more efficiently, and questioning some of like the accepted wisdom on how to organize code, or what's like considered a good program and what's not. I think in web programming, because it's done in these big teams and it lives for a long time, like the software can live for 5, 10, 15, 20 years pretty easily. The focus that most people have there is making it easy to maintain. And kind of the general accepted wisdom on that is this idea of like solid, and these solid principles can guide how you organize your code and make it easy to add to over time, or to modify or whatever. But the point that he makes is, none of the stuff actually has anything to do with anything real. This is all conceptual, and it's really focused on how you're organizing code, and not necessarily on how you like write performant code, or it doesn't relate directly to like the hardware in any way. It's very much just conceptual, and in some ways kind of academic. And I think one of the problems that he has with it is there's also not really a great way to measure this kind of scientifically, to say whether a program that conforms to all of this is actually better or worse. So he's, I think, just generally kind of frustrated with accepting that this is true, when there's not really any like data or studies or anything to show that this actually is better. I mean, I could say like personally from working in a lot of code bases and large code bases and older code bases that just from like the standpoint of managing code and being able to make changes easily, the code that conforms to this is usually easier to change and to test, and there's definitely benefits to it. But I could definitely see his point about like why have we just accepted this as gospel. So anyway, if you're interested in learning more about that, this is a really good video. I'll put a link to it in the notes for the stream. But yeah, he's basically saying, you know, where does bad code come from? And he kind of just goes through where, you know, why he thinks bad codes come about. And I think his definition is largely like revolving around the fact that because he's focused on the hardware, the modern computers and CPUs are just so insanely powerful, especially compared to like, you know, 20, 30, 40 years ago, that there's not really an excuse for anything to be slow that you're interacting with on a computer. And so he's kind of looking at it from the standpoint of like, why is everything that we use so insanely slow and laggy and like bug prone? And yeah, so that's kind of the perspective he's coming from. So anyway, if you're interested in that, I highly recommend checking out any of his videos. Jonathan Blow has a lot of good videos on it, but his are a little less well, I shouldn't say that. He has a lot of streams he's done on the topic. I don't know if he necessarily has any talks that he's done that are more kind of like focused, but he may have a couple. I'll have to look for those. Maybe I can share those in the future. And then another video of Casey's that's kind of in the same vein is like talking through what simple code is from the perspective of somebody who really cares about the hardware, and then being able to write code that is maintainable but takes advantage of the hardware to its fullest. So he goes through this trade-off between simple code and high performance. And this one's more of a conceptual exercise, but he just walks through like he basically starts from like what's possible, like what are from first principles, like what should a modern computer and GPU and CPU be able to handle, and then you know, contrast that with like why are things slow, and then he kind of steps through like how he would make the most of the hardware, or what basically like what's possible, like what you should be able to do in terms of performance versus like what's actually happening. And I'm not sure if it's this video. I'm gonna have to dig through a bit more, but he actually has an example he walks through for an algorithm that he improved for the witness, that was part of the tools that the level designers used, and how he was able to take it just with some pretty small changes. He was able to take it from being something that you had to use and then wait for like seconds, you know, maybe even like as long as 5-10 seconds for feedback, and then see what happens and then do your next change. And the video focused a lot on how to go from a situation where you have these long cycles where you try something and then you just sit there and then you wait and then it does whatever it's going to do, and then you try it again, where it keeps you from being able to, like, as a creative person or just somebody wanting to work on things, it keeps you from being able to try a lot of things because you just have these long cycles. So in the vein of efficiency, he talks a lot about like how do you take things from this situation where you have this huge lag between what you want to do and what the computer can do, to a point where it's real time, or effectively, you know, it seems real time or near real time. So he goes through how he did that with the system that they used to design levels on the witness, and how just with a few small changes, I think in like a day, he was able to get it to go from that situation where it was like these really long cycles of 5 and 10 seconds, or I think even 30 seconds in some cases, down to being pretty much real time. And so it was just a really interesting talk to go through. Some of it had to do with frameworks and trying to reuse code that worked for very generalized cases, and instead replacing that with something that was extremely focused on just his case. And that did a couple really interesting things. One was the code was just purely tailored to what he was doing. He was able to not care about 4 or 5 major concepts that were in the general case. And then also just in terms of debugging, the stack trace, went from something where he had to go through like, 30, 40 layers of code in these in a framework to just within his program that he wrote. So there wasn't all this conceptual overhead too with like jumping around the code base to different places in the stack trace. So yeah, any of his videos, if you're curious about that kind of stuff, I think are very interesting. And I'm probably going to go into more depth on some of these in the future. But yeah, I'm trying to force myself to start spending some time at least thinking about programming from like the perspective of somebody who would be working on something like, say, a game where they're really focused on getting the most out of the hardware and like really getting rid of as much complexity as they can, because it's any complexity you get rid of is just going to give you more performance.